Alright, it's a big day or something. You go through the trouble to buy digital calipers and then you keep forgetting to put the battery in or turn the battery off, so the batteries are always dead. So I just run them as stupid calipers, I guess now. I think that's called a caliper, right? I don't really know what I'm doing. Anyway, this is a 22 tooth sprocket. This is off of a cassette off of one of the donor bikes. I guess we can do this real quick. I found a spot. Oh, I already closed that page. All right. I find a spot in FreeCAD. This is FreeCAD 20.1 under part design. If you click on part design up here, there's a sprocket or a gear. I've added the gear workbench, so I'm not sure if sprocket was there before or not. Right. So I was trying to use the gear workbench, but then I happened to look on Google trying to figure something out. Oh, look at that, there's one for sprockets. So from sprocket, I just typed in 44 teeth. I'm not making this one, in case you caught that. This is a 22, so I'm making the 44 first. And one of the features, there we go. I don't know if that shows up any better or not. There we go. That shows up a little better. So I wanted to make the center of the sprocket a lot thicker than normal because I'm making it out of plastic. So the outer edge of the sprocket is about the right thickness. Oops, we're losing it. But I measured it. That really closely measures the same as the one that I've got. So the idea here, I'm going to put sprockets on each of the Harbor Freight wheels and then use bicycle chains to drive them, at least for the test, because I don't want to wait around trying to get gear tooth belts of the right exact size, because I'm still figuring out ratios and stuff like that, right? So I figured, okay, I do have one of these, but it's actually welded together with another one. So when I was making the turtle prototype, I was welding sprockets just to get things to work faster. So not a long-term solution, but I'm like, well, I had a whole pile of them, but now I don't want to unweld it just to get it out. So I thought, well, for testing, this should be good enough. And if I don't expect it to last a really long time, but I'm printing it from ABS, and that is actually pretty strong. Okay, so I compared that to a 44 tooth sprocket that I had, and it measures right on, so I think we're pretty close. I mean, if it measures right, it should be about right. So the next step, I got it over here on the 3D printer, so we can go through the menu here. Print from SD. There's my 44. Okay. This guy will come into life. So it's not really warm today, so it's going to kick a lot of energy trying to warm this up. So this one is going to go up to 245, and it's at 17 now. And this is going up to 110. This is Celsius, so that's hot enough to boil water. This one is for the bed, and 245 is for this. That's where the plastic comes out of. This draws an enormous amount of power. Well, it pulls 400 watts when it's heating. I know on a good sunny day like today, I have been able to run a 4-hour print before. Alright, for example, this part here, it's about 2 inches thick. That takes 4 hours to print. And we're printing these holes into the part that we're making, so they are going to match, hopefully. Sprocket! So we'll say it's almost done the first layer. It's been going 39 minutes now. About 2 hours later, the printer says it's been running for 3 hours exactly right now, and it's more than halfway done, so yay for that. Alright, we're done. 4 hours and 49 minutes. I think we got a good print, and we get to test it tomorrow. Or someday. I still got to print the other sprocket. This goes on the wheel, and we'll put a little one on the motor. This will give us 2-to-1 reduction, so it'll be like granny gear. Got holes. Printed the holes into the design, should match. I'll use some simple screws. I think that'll be okay. If I pre-drill them 1/8 inch, should be good. And try to catch some of the chips in the bucket. Just cut down on contamination out here. I think these will be okay. Let's just try one and see. I don't know if this will split or not is the question. Oh, that'll be fine. Good, okay. So, let's see. There's a little bit different offset on one side or the other, so we'll just stick it out and see if that looks okay. On the drill on this to give me a clearance hole. I don't need these to thread in, they're just going to bite into here. Oh, that's nice. Okay, it slip fits through, but it barely moves, so that's actually good. I think I'll do these by hand. I don't want to power drive them through. Holes aren't quite perfect. Oh, I think I know why, now that I think about it. When I made the first part, I didn't have my process down very good, so my holes aren't quite true. Okay. I think the holes on the sprocket are better, but the holes in the part itself, I didn't get the spacing really good. I'm still learning FreeCAD, and there's a, well, I kind of did the holes as an afterthought, so I just kind of like set them equal spaced so I had enough room around it so that they wouldn't split off. But I don't know that I got the pitch exactly the same all the way around. I don't think I did. So what I can do, I'll play with this and see if I can find at least a few that'll work. As I build some of these, I'm going to learn the process a little better, and then I can start making more precise parts. The 3D printer is awesome. It's just I got to learn how to do the CAD a little bit better. It's got a good gap in between, and the way I set this up, I've got some spacers left over from, I think, the motorcycle wheel kit that I bought that'll fit this. So we'll slide this on. The spacer will keep the sprocket from hitting. It's got lots of room. In fact, it's probably too big. I could run longer bolts because these bolts aren't quite long enough, but for now that'll be a good starting point. It's going to stick out a ways, but that's fine. That gives me lots of room in between. And a couple days ago when I was mocking this up, yeah, the bearings are a little bit tight. I thought tightening it down was actually dragging on the bearings, but the bearing itself is tight. I should be able to tighten it down without any worries. The wheel itself is a little bit lumpy. The sprocket's pretty true, actually. Good. Alright. That's running pretty good. There's a little bit of the support material is left sticking out here. But I checked this sprocket on one of the bikes inside, and it seems like it's going to work. The other sprocket that fits on the motor, I made it a little bit too thick, so that's going to be a problem. I think if we clean this up, it'll be okay. Now that I got our shot set up, there's our little sprocket. This is 22 teeth and this is 44, which will give me half speed reduction basically. This turns, I wrote it down, I'll put it up on screen, but it's somewhere around 40 RPM and 60 RPM, low speed and high speed. So it's got two speeds built in, so I can switch where the wire connects and I can change my speed there. I need to make sure that the bolts don't hit, which they will. And I put the added thickness on one side just to give me a little more rigidity here. So I'm going to take the bolts off for now. I think eventually I will use these bolt holes for a mount, so I got to work that into the design. Two ways I can look at this. This shaft coming out of the motor is tapered and they got splines on it even. So if I could make an adapter that would fit that, slide it in and then just tighten the bolt and the spline should dig into the plastic, that'll be good enough for a start. And then after that we'll kind of see how it turns out. I'm not going to solve all the problems the first time. I'm looking at it, it's like, well, how hard do I have to try for this to work at all? Yeah, that'll work. Okay. Making sure we can see what we're doing. Get that out of the way. So this will fit, at least without the bolts, I got room. Let's try it this way. So I got the hole pretty close. When I push it down on the splines, I can grab where my nut is. I think I can get enough to make that engage. Once it's engaged, I can push it down over the splines and I think it'll lock. Got to be careful not to split it, but I think we can get there. Oh, this is going to be good. Yeah, I think that's going to work. Okay. So what we're going to want something like this would work, as long as they're in line, and then figure out how close I can get it. I could also, just for a test, make a chain and hold it in my hand and run it, just to make sure it's going to work. Because what I want to do is get an idea how much actual torque and speed do I have at the wheel before I get too far. For instance, I got it now at 2-to-1 reduction. Is that a good range? I'm not sure. You know. Plus, I do have the electronic speed controller, so I can slow it down. I just want to make sure I can go fast enough, or whatever. All right, so we'll stop and we'll think about that for a minute. Okay, couple of things. The sprocket on the wheel is about the right size. This one is too thick by maybe 1 millimeter or 2. I don't know that I actually thought about that when I made it. I thought I was okay, but it is definitely too big. There's also two sizes of chains that I have. They're both bicycle chains. One is for single speed and one is for bikes with multi-speed with a derailleur. The derailleur chain is narrower to fit between all of the different sprockets, or to catch every sprocket. If you ran a single speed chain on a bike with a derailleur, it wouldn't work, basically. So if you ever run into that, that's why. Anyway, so this is too big. but I found some single speed chains laying around. When I was taking all the bikes apart, I saved a bunch of chains, and some of these chains were really rusty, but I soaked them in penetrating oil for a while, and I got some of these to free up pretty good. So I'm just thinking, I had checked it on single speed. It's not way too big. So I can check it with the chain, just kind of lay it on there and see how it's looking. Also, it seems like the template I was using, the sprockets come too much to a point, so I might, what I can do after I get them narrowed a little bit, they should have a narrowing taper to them anyway. They should have a little bit of a bevel, so the next time I'll try to print that into it. But for now, it's easier to just modify this a little bit and get to the next step, and then eventually I'll make a better one. Because I'm going to have to make 6 of each of these. So I'm going to try to work through the details here first before I duplicate it. I did make 2 of these, but also these are, I could make them smaller, right? This is a 22 and the one on the wheel is a 44. That gives me 2 to 1. But I could just as easily do, instead of a 44, I could do a 36 and make this an 18, and I'd still have 2 to 1, right? The other question though is I wanted to see, before I get too far, what if I needed to really change my ratio? If I drop this 22 down to, I think what the smallest one I have, 14 or 16 or something like that, I can make it pretty small. That would give me 3 to 1 to reduction. Okay, so I want to see how close I am first, and I need to test it before I get too far, but at the same time, I don't really know the weight of the robot yet, and so it's kind of like you're going in a constant circle. I may have to go back and completely change the ratio here. But that's one of the neat things about being able to make my own sprockets. If I have this design in the computer, I can go back and I can make a different size sprocket with the same size hole, print it off, and this took 1.5 hours. The other one took 4.5 hours. So the smaller they are, the faster they can print, the less power it uses, which means my batteries last longer out here, because I'm not, I'm off grid. So anyway, and the other possibility is I could test this with a drill, with, and just make it spin and make sure that part's at least looking like it's going to work before I even hook it up to the motor. All right. And I got plus I got a 2-speed transmission on here. I would love to put this on the robot. That's something I'm going to be looking for, because I know you can buy that. So you can buy the motor with the transmission and an output shaft. So this is 1st speed. That's got a lot of torque. All right, that would probably break the teeth if I was pushing a heavy load. So that's got a lot of, it's a little tiny motor. It's smaller than the wiper motor. By the time you get inside, it's a really small motor. This is overkill, really. But I got 2 of them, so we'll use that for a starting point. So I got a file and a kind of a rasp, so I'm just going to try it like this. Oops. Might have to actually tighten that down. Alright, this one actually is laying in pretty good. I just went around it and knocked the sides off a little bit, so the chain is laying right into the teeth now. It's a little bit tight, but I gotta figure this is going to wear in pretty quick anyway, so I wasn't spending too much time on it. I just literally just a couple minutes. And part of this one, the support material was here. When I 3D printed it, there was some extra plastic that was printed to kind of just fill in the shape. So as I peeled that off, and then I just went around with the file just a couple times. It's a little bit beveled this way, but I didn't do the inside yet. I could later, but for now I don't think I need to. Seems like it's going to be good enough for today's test kind of thing. I'm going to be watching if the tips of the teeth are a problem. I think they are going to be. So we'll just kind of keep an eye on that. And this one, I think, is still too thick. Yeah. That's got to go a ways yet, so Give that a little more time. We're getting there. Some time has passed. I got the little sprocket closer, but not really a good fit yet. I'm at the point, one of the issues, these are printed hollow, so they have what they call infill. So you got 2 or 3 layers of solid plastic on the outside, and then anything in between that has kind of a honeycomb. It's more of a square pattern, but basically think of honeycomb in between. They're still really, really strong. However, if I start sanding down any further, I'm going to start hitting that honeycomb layer, the infill. So it's not going to be much good to us anyway. So I thought for now, it's kind of close. The chain is probably not going to track really good, but I just wanted to try it out. So since I've got it on the drill still, I'm going to go ahead and do that. I cut down the chain, and I've got a well, not a master link, I should say. I've got, basically I took the grinder and took the rivets off of the chain, and we'll call that good enough for now. So I'm going to just sit here and hold this and see if it's tracking at all close enough to even think about trying to use it or not. If not, then we'll, ultimately I'm going to reprint this maybe tomorrow. It's getting late in the afternoon, so I wouldn't have enough time to print it now before I run out of daylight. So let's just see what it looks like. Let's see, are we on slow? Let's put it on slow first. Well, I'm not quite straight, but I'm definitely not staying on the teeth on the little sprocket. This is not ideal, but I just figured it'd be faster to try it this way than to try to make a mount for it and then find out it doesn't work anyway. So, there we go. Okay, the big chain, or the big sprocket isn't quite there either, but it's closer. Okay, I think the teeth are too tall. That was something I was kind of concerned about. The teeth are so tall that they're catching the chain, it's not releasing it like it should. I don't know if that makes sense or not. I'm not sure if I can show you easily with this setup. But the little one, I did shorten the teeth, and that seemed to help. Yeah, they're standing on top instead of falling down, and so then it throws it off. Okay, so I'm not going to even worry about hooking up the other sprocket then on the wiper motor yet. Okay, so now I got a starting point. I think this one is close enough. I'll spend a little bit of time filing the tops off because the rest of it seems like it's basically working. So if I knock the tops off just a little bit, I think we'd be fine. So that's a good start. Shoot, it's been 4 days already. I was like, okay, my only goal for the day was to get to this stage, and we're still not quite there. I'm making a mount for the wiper motor. Okay, we'll call this kind of a not very working in progress. So that's the new printed sprocket, and then I went around with my nips and cut the tips off the points because they were sticking out too far. And I just figured I'd take a little, just cut them off. It went really quick. And then this is the one from before. That's more or less working. I don't have really good control over the chain right now. It's not going very straight. Things are a little bit twisted, so what I'm doing, I'm just holding this in my hand. Alright, so basically I've got the speed controller that we had before. So I'm just going to hold this in a position that's kind of straight looking. Ish. If I can get it close, it does work. It's just not really very good. Really like to get this going fast enough to see what it looks like, but we're kind of struggling there. It's just hard to keep everything aligned, and actually I think part of the problem, this sprocket isn't even running true, and I think that's actually the wheel. So hooking up where I am on the wheel isn't as straight as I would have hoped. Going forward, I think I'm more likely to do something like a V-belt. So this was a neat test. And the other thing is, I mean, over, too strong is fine, but I don't need the complexity of a chain drive. I just thought it was a kind of a handy way to make it work, but it kind of binds up sometimes if it's not perfectly aligned. So I'm just kind of leaving it slack. Okay, that's about full speed. That's full speed on the slower setting on the motor. I think that would be okay. And yes, I had started off trying to clamp it in position, then I realized that the sprocket itself is part of the problem. It's just not running true enough. The chain isn't feeding into the sprocket, and even when it's pretty straight, it still jumps around a little bit. So it's not as good as I could have hoped. Okay, that's wide open. 1, 2, 3, 4. Okay, that's how fast the RPMs are going. I can see the valve stem. Oh, I want to get that on camera. Just don't grab the spinning bits, right? Okay, that's wide open.